Hello everyone. Now in today's lesson, I'm going to continue on from similar triangles, except in today's exercise, there will be similar triangle proofs, which can be quite challenging, so just please pay attention. Now I'm going to go through exercise 1001 in the signpost textbook. So let's just quickly get started. Now we know what similar triangles are, as we know that two figures are similar when one figure can be enlarged and superimposed on the other so that they coincide exactly. Similar figures have the same shape but different size. So what this means is all circles are similar, right? If you enlarge one circle, you can get to the bigger circle. And just for a quick recap, there's the 4 proofs of similar triangles. Two triangles are similar if the lengths of matching sides are in the same ratio, right? So that's the first one. It's kind of like your triple S in congruent triangles. Two triangles are similar if two angles are equal to two angles of the other. So if you have two angles equal, that means all the angles are going to be equal, so they're similar. They're similar if the length of two pairs of sides are in the same ratio and the included angle is equal. And the last one is the two sides in the same ratio where one is a hypotenuse and there's a 90-degree angle. So I'm not going to go in through these in depth because you should by now already know them since you've done so many similar triangle exercises. Now I'm going to go through some of these harder examples, and I want you to carefully pay attention to this because these questions are not straightforward. Okay, and they're not straightforward. The main reason is because you need to know how to write your reasoning, and I know that's an area a lot of you need to work on. So let's just take a look. Okay. Alright, so I'm just going to enlarge this just so that it's more clear. Okay. So the question says AB is parallel to DE. Prove that triangle ABC is similar to triangle EDC. Hence, find the value of x, and units are in meters. Okay. So let's just take a look at this question. So the first step is to do this, right? Prove that triangle ABC is similar to triangle EDC. Now, how can we prove that? So now we know that we can't use the sides because we only know one side of this triangle. Actually, we know 3 sides of this triangle and we know one side of this triangle. But we can't use the similarity proof for sides because you need to know at least 2 sides for that. So then what we can do is this. We know that this angle is equal to this angle, right? Because of what? Vertically opposite. And we can say that this angle is equal to what? This angle. Because of what? Alternate angles, right? So then once we found 2 angles of the 2 different triangles are equal, then we can just say they're similar because of equiangular, right? So then let's just get started. So in triangle, make sure you write the triangle in the same order as this. And make sure you write this introduction because I know there's some of you that likes to take shortcuts. In triangle ABC and triangle EDC, so you can say angle ACB. And every time you reference an angle, make sure you label all 3 points. So don't just write angle C when it's angle ACB. Angle ACB equals to angle, say, DCE. And the reason for this is vertically opposite angles. Opposite angles. Make sure you write the full word. And make sure you give a reason here. Okay, this reason is very important. Because I know there's some of you that don't like to write this kind of reasoning. And then we say angle BAC is equal to angle, say, CED. Right? And the reason for this, well, this is alternate angles. Alternate angles, and then we need when we say alternate angles, we also have to state the parallel lines. So AB parallel to DE. Okay, so now we have two angles that are out of the way. Then we can just say they're similar because once we know that 2 angles are equal, the third one has to be equal. So we don't even need to say the third one is equal. So therefore, triangle ABC is similar, 3 vertical lines. Triangle EDC, and the reason for this, now we're pretty lucky because this is the shortest reasoning one, equiangular. Equiangular means all the angles are equal. Okay. So then we've done the first part. Now the next part says, hence find the value of x. Okay. So there's a few ways that you can do this. One is so you can visualize which matching sides are they. The other one is to just draw the two triangles out, which you can if you want to. Okay. But I mean, what you can do is just turn this triangle the upside down until it looks like this, right? But I mean, if you want to draw it out, that's fine. So I'm just going to draw it out just to make it clear. So we already have this triangle drawn, right? So I'm just going to draw. This triangle is already drawn for us, right? So what I'm going to do is I'm going to draw this triangle ABC, but in the same the orientation as CDE. So then what that should look like is this. So you have a dot at the top, you have this, you have an A, you have a B, you have a C, right? And then we know that AC is 4, BC is 5, AB is 6. So then to find out what the X is, just make sure you have the matching sides divide by each other. So we know that X divided by 5 is equal to 9 divided by 6, right? So hopefully this part makes sense. So, and the reason for this is her matching sides of similar triangles in proportion. So that means if I divide the two sides, so this side by this side, I should get this side divided by that, right? So then once we get this, we just solve for x. X equals to... Now remember, the reason you can write this down is because you've proved that they're similar already. So if you don't prove they're similar, you're not allowed to actually write this. This is 45 on 6, which equals to 9, right? Oh, sorry. Which equals to 7.5. Now, because it's in meters, you just write 7 in meters. Okay, so that's the answer. Now, hopefully that's kind of clear, but I kind of expect you to know how to do the first part here. The second part is actually a bit more challenging, and that's why you're doing this exercise with me, because this is the second part is the hard part. So you basically need to, it's kind of combining two exercises into one. All right, worked example 2. Now, this is an even harder question, so I'm just going to crop it here. Just give me a sec. So it says in the diagram shown, E is the midpoint. Okay, so I'm going to copy this as well. Okay. Just going to make it a bit bigger. So let's take a look. In the diagram shown, E is the midpoint, okay, of AC and the ED. So because E is the midpoint of the AC, then we know that these AE and EC are equal, right? And ED is parallel to AB, okay? Prove that CD is equal to DB. Okay, so this is a tough question. And the reason it's a tough question is because you need to kind of know what you need to do. Now, the question doesn't actually show you or doesn't ask you to prove that they're similar, but it's kind of implied. So once you've done these questions enough times, you know that when you get a question that looks like this, and you got to prove that CD equals to CD equals to DB, you have to prove similar triangles. Now, the reason it's not congruent triangles is because there's no two triangles in here that are the equal, right? So then let's prove two similar triangles. And the only similar triangles that I can see is triangle CED and triangle CAB, right? So prove that they're similar first. And then I'll explain to you why we need to prove that they're similar. So write the introduction in triangle CED and CAB. Now, what do we know? We know that this angle is common, right? So angle ECD is equal to angle ACB, right? And you can just say that's common. And you can say that this angle is equal to that angle, right? Because of what? Corresponding angles. So angle CDE is equal to angle CBA. And the reason for this is corresponding angles. And what's the parallel lines? So it's ED and the AB, right? ED parallel to AB. Okay? So then you can just say, therefore, triangle CED is similar to triangle CAB. And the reason is the same as above, because we've proven that two angles are equal, so then the third angle has to be equal as well. So you say equiangular. Okay, now, so how do we use the fact that they're similar triangles to prove that CD is equal to DB? So we know that CE, so that's from the small triangle, divided by CA. It needs to be equal to CD divided by CB, right? So this side divided by, so this is the black side is the side of the small triangle. The red side is the side of the big triangle. So the black side divided by the red side should give you the black side divided by the red side, right? So the side from the small triangle divided by the side of the big triangle is equal to the side of the small triangle divided by the side of the big triangle. And the reason for this is the same as above. Matching sides of similar triangles, they're in proportion. So I'm not gonna write the full thing, but it's basically this, okay? And you just write it here, okay? Okay, so then we can say that now, because we also know that CE, this is going to be half of this, right? Because this is the midpoint. So CE divided by CA is equal to a half. So actually, I tell you what, so I should also write is equal to a half here. Okay, so we can just say that CD divided by CB is equal to a half. Right? So we know that this CD divided by CB is equal to a half, right? So then we can just say that CD is equal to DB, right? Therefore, CD is equal to DB. Alright, so these are the two textbook examples. Now I'm going to go through some questions. So, for question 1, now question 1 is going to be a bit easy because it just asks you to prove the two triangles are similar. Okay, and then he asks you to find the value of the pronumeral. So in this question, I expect to see full working out. I don't want people taking shortcuts. Okay, so I'll be paying attention to that. Question 2 says, state what condition could be used to prove the triangles are similar and then find the value. So, yeah, what condition could be used to prove the two triangles are similar? So, for example, for question E, right? Question E, so you can just say that triangle AEB and triangle ADC, you have an angle that's common, and then you have an angle that's equal to this angle because of corresponding angles. Therefore, they are similar because of what? The equiangular, right? Okay. So, I'm not going to do question 2. Question 3. Now, question 3 is kind of similar to the example that I went through, so I'm going to skip that. Okay. Question 4, question 5, question 6. Okay, so I'm going to go through question 6, okay? Because it says, from question 5a, we see that a line parallel to one side of a triangle divides the other two sides in the same ratio. So what that's saying is this. So if you have it says a line parallel to one side of the triangle. Actually, I'm going to copy this as well. So, a line parallel to one side of the triangle. So that's the one side. A line. Oh, sorry. So this is the one side. A line parallel to one side of the triangle divides the other two triangles in the same ratio. So what that means is this line divides those two lines in the same ratio. So what that means is this. That means the ratio of 26 to A is the same as 28 to 20. So these two sides need to be in the same ratio. So then how do we work out the value of A? Well, you can think of it like this. You can just try to... You can write this in a different way. You can just write 26 over A is equal to 28 over 20. Okay, and then you just solve for A. And that's how you do it. Now to solve for A, what you can do is you can flip both fractions if you want. So A over 26 is equal to 20 over 28. So then A equals to 26 times 20 on 28. And this should give you can use your calculator. So you have 26 multiplied by 20 on 28. So you get that number there. You can turn it into this number if you want, the 18 and 4/7. Alright, so that's how you do question 6. So that's pretty easy. You don't actually have to give any reasoning. I'll have a look at question 5. Okay, so question 5 seems a little bit challenging, so I'll just take a look at it. Question 5a. Alright, so let's take a look. So it says, actually I'm going to move it here. So it says D divides BC in the ratio of 4 to 5. So what that means is this. So this point divides this line in the ratio of 4 to 5. What that means is this is going to be 4. This is 5, right? Divides it in that ratio. And AC is parallel to ED. Okay. Now, if BA is the 35 meters, so saying if this is 35 meters, prove that triangle EBD is similar to triangle ABC. Okay, so now that should be pretty straightforward. So you can see that in okay, so I'm just going to quickly go through it. So in triangle EBD and triangle ABC, so you know that angle EBD is equal to angle what? ABC, right? And the reason is common. So this is similar to the other questions that I've done. So angle BED, so this angle is equal to this angle, right? Is equal to angle BAC. And the reason for this is corresponding the angles. And you can say ED is parallel to AC. So therefore, triangle EBD is similar to triangle ABC. And the reason for this is because we found two of the angles are equal. So it's equiangular. Okay, so that's the first part done. Now part 2, find the ratio of BD to BC. Okay, well, now we know the ratio of BD to DC is 4 to 5, right? So then the ratio of BD to BC should be what? It should just be 4 to 9, right? Because 4 to the whole length, so 4 to 9. So that's pretty easy. Find the length of BE. Okay. So because we proved that those two triangles are similar, right? So we know that, okay, so we know that BD over BC, that needs to be equal to BE over BA, right? And we know that the ratio of BD, and the reason for this is matching sides of similar triangles in proportion. Right? So I'm not going to write that because it's quite long. So then we can just say that BE over BA is also going to equal to what? 4 over 9. So we know that BE over BA is equal to 4 over 9, and we know that BE plus BA, BA, we know that BA is 35, right? So you can just say BE so we can substitute the BA length into here. So then what's BE? So then you can say BE is equal to 35 times 4 over 9, which equals to, okay, this is a fraction, so 35 times 4 over 9. So 15 and 5/9. So that's the length of BE. Find the length of EA. So how do you do EA? Well, I mean, if BE is 15 and 5/9, then what's EA? So EA is basically, you have to take away from 35, right? Because 35 is the full length. Take away 15 and 5/9. So this should give you what? 19 and 4/9, right? Meters. So, alright, so let's take a look at the next question. The ratio of BE to EA. So now we know that BE is equal to 15 and 5/9. And EA. So I should tell you what. So you can just say BE to EA is equal to 15 and 5/9 to what? What's EA? EA is 19 and 4/9. So you just divide these two numbers on your calculator and you should get the answer. So just do 15 and 5/9 divided by 19 and 4/9. And what you should get is, let's see, you should get 4 to 5, right? So then the ratio is equal to 4 to 5. And that's expected because we know that the ratio of BD to DC is 4 to 5. That means BE to EA should also be 4 to 5. Alright, now let's do the last question before I wrap it up. Show that ED divides BA and BC in the same ratio. Show that BE on EA equals to BD on DC. Okay, so it's a strange question because we've already shown that. So we've already shown that BE to EA is 4 to 5, and we know that BD to DC is also 4 to 5. So I feel like you don't actually, this question is already done for you. So, I mean, if you really want to write an answer for this, then you can say, since D divides BC in the ratio (4 to 5), therefore then BD to DC is equal to 4 to 5, right? And BE to EA equals to 4 to 5, and the reason for this is, well, shown in part 5. Therefore, BE on EA is equal to BD on DC. Alright, so I think that should be all that you need to know. I mean, these questions are pretty challenging, so don't worry too much if you can't do some of these. And as always, if you have any questions, just feel free to send me a message. Thank you for listening.